According to the World Bank, humans produce approximately 3.5 million tons of waste per day. Over the next 15 years, we are expected to grow this number to almost 6 million tons of trash every single day. I live in Dubai, one of the fastest developing cities in the 20th century, facing a major waste problem. Dubai residents produce more than 2 kilograms of trash every day per person, and the recycling of this waste is barely noticeable. The Dubai Municipal Organization has been taking some key steps in the infrastructure and planning of public areas and its policy making in order to encourage the efficient disposal of waste. However, key steps must be taken in order to normalize waste allocation throughout the public. When I got to learn about this local waste problem, I decided to restore an idea I received from a club that I participated in throughout my junior year. The club aimed to reduce the trash problem and worked on a then unfinished smart bin called Trashberry. Picking up from the unfinished project in the summer of my junior year, I had a general idea of what I wanted to do. However, I still had to plan both the technical and physical layout of the product. After brainstorming, I developed a basis for a project that would use a webcam connected to a laptop to identify objects and indicate to human subjects which bin to place their trash in, allowing for the greater efficiency in the separation of waste. This would enormously reduce the time taken for organizations and governments in sorting recyclable and reusable trash products. The final product uses a normal webcam and a CPU to identify different types of material put in front of it. If it recognizes a specific item, it plays an audio indicating to the human subject which bin to place the item in. The algorithm classifies whatever it sees into three main groups. The first group is the food waste bin. This takes into account all fruits, vegetables, and foodstuff that have been fed into the TensorFlow library. This feature is especially helpful in company cafeterias or parks where the application raises awareness about compost and the effective disposal of food waste. The second classification is the e-waste bin. This feature recognizes all pieces of hardware from old mobile phones to keyboards and indicates to the user to dispose them into the e-waste or electronics bin. The problem with electronic waste is that it contains hundreds of small plastic components that lead to hordes of microplastics in our oceans and landfills. To ensure actions towards the safe recycling of electronic waste, the Trashberry algorithm indicates to the user where and how to throw his or her electronic waste. The final allocation is the glass waste. This takes into account glass bottles, screens, and jars that can be recycled by users. Recycled glass has multiple applications and has now been proven to be one of the key components in the creation of AstroTurf and brick manufacturing. Over the future, I hope to bring this change to the global society. By creating trash cans inbuilt with the Trashberry source code, organizations and governments can implement the power of technology to help with primary waste allocation. Additionally, using the same artificial intelligence technology, machines that physically move trash at recycling plants and landfills can be created. This way, landfills and recycling plants can seamlessly assort products while wasting effectively no time in the manual categorization of waste.